Recording's going, screen sharing's going. All right, everybody online can hear me and see my screen.
Yep.
All right, awesome. Okay, so a couple things. First of all, hopefully most of you went to the Tech Talk last night on Zoom. I put that up on Slack a bunch of times this past week. It was Mike Gardapi from Skygen USA is the name of the company. They're here in Mequon, and they also have an office in Menominee Falls. So Tech Talk was last night, 6 to 7:30. I think they recorded it. If you did miss it, it was a really good talk. Lots of good questions were asked. And actually, since last night, there's already been one intern hired and one person who looks like they're going to be moving into a full-time position starting in May. So that's a company that we've worked closely with, and there's lots of opportunities for internships through them in the software development field. We currently have, I think, 4 or 5 students that are interning there at various levels. Related to that, I don't know the date for this yet, but we're going to be doing a session kind of similar to what last night was in terms of length or whatever, but it's going to be on mock interviews for internships and also jobs for computer science, where it'll actually be run by a group at the university who does these, and we'll add to that for the specifics related to, interviews for software jobs and things like that. So that'll be something to, kind of attend, listen to a, initial tutorial type thing, and then there'll be breakout rooms to practice, mock interview type stuff. So keep a lookout for that. Let's see. So next for homework today, you were supposed to have gone and looked at Code Wars. So hopefully that got you an account set up and gives you an alternative way of practicing some stuff. I've messed with it a bunch, and it actually seems like it's a pretty good way of at least letting somebody else come up with little puzzles for you to try to solve. So I would encourage you to keep working on that. What's also nice is it has a lot of different languages supported. So as you move through our program and you want to practice in whatever language, like next semester, for example, you're going to be in 250, you'll be switching over to Java. Not that it's a big deal. I've advertised in here that programming is programming. The language doesn't matter, but it'll give you the opportunity to practice some things doing the equivalent of what you already know how to do or reasonably know how to do in Python. You'll do that in Java, that type of thing. So again, a good tool. I've only recently been introduced to it, but students have been asking for ways to practice extra outside of class, and I know it's hard to come up with examples. So this is at least low-hanging fruit for trying that, I suppose. Okay, so now that we have some background, and I've kind of promised that we're going to be moving towards object-orientedness for most of the rest of the semester, we're going to start trending towards making a game. All right. And it's going to be all text-based. It's not going to be pretty looking, but it's going to allow us to have multiple objects at play and allow us to introduce many of the concepts that are coming up in the rest of the semester. Let me get down to wherever I am here. Why does it not show me actually what I have highlighted? Okay, so what I'm going to do is I'm going to create a new slide here. And what we want to do is we want to create a model. So we're operating off of this idea of how object-oriented languages work and why we might want to create objects. And so now we want to start thinking through a real-life problem. It's a video gamey problem, but it's still a real-life problem where, let's say we have the main computer science suite across the hall there. So if you were to kind of draw a hand-drawn map of that room, okay, of that area, you kind of walk in the doors and you have that little hallway, and then you can go right or left from there. And there's a classroom down there to the left. There's the lab down straight ahead, so on and so forth. So you might kind of draw a map. Now, what I want to do is I want to draw a map that is in the context of rooms. All right, so we're going to think of it like we're building the department out of Legos, where our building blocks are something called a room. All right, so I might create, let's see, I'm going to need to move this to get to my jazz. I think that'll let me accomplish it. All right, so I'll go ahead, and this might be the main entrance. Maybe that's a, kind of a double length hall. And then we can kind of turn down the hall down this way. Okay, and then from here, so maybe this is what 1A S118B, I think is that classroom. This is I'm just going to call this Mac Lab. I don't remember what the name of the thing is. All right, so we have that. There actually is a little room over here. We'll just forget about that for our little example right here, because I think most of you probably haven't been in that room. It's an extra little lab thing down here that it's going to be our network and security sandbox. So, you know what? We'll mimic it. Why not? So we'll call this security sandbox. And then let's see, go in the other direction. We have S120. It's kind of shaped weird, I guess, that room. We'll just pretend like it's this. Call this esports. And we have a little lobby area there. The laser cutters. We can call that like a boss fight. You have to go in and fight the laser cutters, something like that. How many of you have ever used a laser cutter before? They're totally awesome, especially when you're first setting them up and you haven't wired it right. And they start fires and like blow you back across the room. It was really, really cool. It was one of our big ones. We have 2 of them in there. Now they're safe-ish. But they let you do some really cool things. Cutting out pieces of wood. We could probably do thin pieces of metal, but so these are things that between that and the 3D printers we have down in the makerspace, things that'll let you invent some stuff as you go through the program. So make sure you, if you do have an interest in 3D printers, I know some of our classes do introduce them. You probably are seeing them some in 175 maybe, or maybe he's at least talked about the 3D printers or something. I don't know if he's done anything with them, but if you have interest in using a 3D printer to start creating little widgets and gadgets and inventing things or whatever, it's free for the computer science students. We give you free plastic and everything. And we have Blade is our manager down there. You've probably seen him around the department. He's one of our grad students, Chinese guy. But we call him Blade. His official name is Yiming Liao, but he goes by Blade. And he can teach you how to do some basic stuff. And then from there, you can start inventing stuff. But the laser cutters are really cool for that too. Like we use the laser cutter to cut out this shield that I'm wearing. So this was a piece of plastic, and we have a thing, you just put the plastic on there and it cuts out like 3 shields in 12 seconds, something like that, with perfect precision and that kind of stuff. All right, so we have our laser cutters there. Then we have a network room. We'll call this server room. So even though maybe you haven't been in all those rooms, that's roughly what the computer science department looks like, right? It's where these are our hallways. So, this is the big long corridor hallway. This is the main entrance. We can call this guy entrance. This is maybe, I don't know what we would call this, the lobby or something like that. And this is that hallway that leads to the different classrooms. All right, so everybody should recognize this at some point. Well, I say everybody should recognize this at some point, but given that this is, for some of you, your very first semester here, if you're strictly an online student, you may not have been to campus yet, so you may not recognize this, but this is what the computer science suite looks like. We're actually currently across the hall here, down at a room right over here, that we also have as one of our rooms for overflow, whatever. But in any case, we're going to try to create a computer program that mimics this as a starting point. Now, eventually, if we fast forward a little bit, what we're going to do is we're going to have this as like this map, the world that our player can live in, right? And then our player will get put into this entrance and he'll be able to walk around this map and see the different rooms. Then he'll be able, maybe we'll put monsters in there. He'll be able to fight monsters. All right, so, you know, maybe we'll put Dr. Locklear in the laser cutter room. Probably some kind of, I don't know, sword, lightsaber, probably a lightsaber. Okay, that makes sense. But whatever, you know, we'll create kind of a little game aspect out of it. But we want to start with saying, hey, you know what? I want to model the map of the computer science department, for example. And I've decided that the way I'm going to represent an individual section of the department is in an object that I'm going to name room. Okay. So we might say, and I got to go back this direction. I'll just do that. So we might say we're going to create an object called a room, and we're going to say that a room has a name, and then maybe a room also has a description. Okay. Now, a room should probably also have a list of exits, right? Directions you can go from a room. So if I come back to this picture here, when I first come in here, I only have an exit back to the south. We just use cardinal directions. I can go back to the south, back into this main hallway here, or I can go north into the main corridor of computer science. From there, I can go east. I don't know if we're actually traveling east, but on our map, this is east. Okay, so we can go east again. Now from this room, I can go north, I can go south, or I can go east. Okay. Now from this room, I can go north or I can go east. Now there is a wall here in the computer science department. So I actually can only go west from this room. I can't get from the security sandbox into the Mac lab. If I want to get to the Mac lab, I got to go west, then north, then east. Okay, so this room would actually only have one exit leading out of it, even though on the physical map here, it might seem a little different. Okay, so we want to create this kind of setting. So we have these little connecting pieces between these rooms. So what I can do is I'll put a little, make it look like this. Maybe make it green. So we'll have a connecting piece here, here, here. Also, we can't get to the server room from here. We have to go around this area to get it. All right, so something like that is the actual map of the department in terms of how we can move between rooms and that kind of stuff. So our the blue things here are rooms, and then the green things are our exits. Okay, so we want to think about, you know, we have a room which has a name, it has a description. You know, in fact, maybe we don't actually give it a description. Descriptions are sometimes, you know, like, what are we supposed to say? It's a hallway or something like that. So just to keep it simple, we'll just have it has a name and it has a list of exits. So we'll call all of these guys, you know, we'll call this entrance, we'll call this hallway. This used to be called, students used to call this the soda, what do they call it? Soda room, soda machine room, something like that. We used to have a soda machine in there. It's now out over here somewhere. But in any case, you know, we can name the rooms whatever we want. But each room will have a name, and then it'll have a list of exits. So this particular room here has an exit to the south, to the west, and to the east. Okay, so in our model here, a room is an object, and we're going to have to create several instances of room objects in order to represent this. So what do we got? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 rooms. We're going to have to create 14 individual instances of our room object. So last class we talked about classes kind of representing like a blueprint, and we can use that blueprint to create new objects. Okay, now when we first create these guys, they're just sitting there disconnected from each other, right? You know, I can go, so let's just create this guy initially. So initially, I'm not even going to give him his list of exits. We're just going to have a bunch of rooms with a bunch of rooms that just have names. Okay, so we're going to create these guys. So I'll go back to my map here so I can easily see this. And we're going to call these guys hallway, just so all of them have a name. Call that good enough. All right, so I'll go over to my program over here. I'll go ahead and dump out main. We'll get rid of all the stuff up here. All right, so we're going to go ahead and we want to define our object. So at the very beginning here, we've decided that a room is just going to keep track of a name. We kind of know that we're going to add some more stuff to it, but just as our initial step, because I want to really grow into this idea of when do we use objects and why. So we're going to create a class here called a room. Okay, and we've decided that in order to create a room right now, all we need is a name. So we're going to define the init method. This guy's called, what's the init method referred to in object-oriented terms? We were working with this in a language like Java or C#. This method right here represents what as far as object-oriented programming is concerned?
Self.
Self is going to be grown in there. But in terms of members of a class, we have fields, we have methods, and we have constructors. Which of the things is this guy?
Constructor.
So init is a constructor. It's the guy that initializes our object, and we're going to see us use it here in a minute. Okay, so this constructor will take in a single parameter along with self. Self is just the required syntax for how Python's objects work. And we'll just say self.name is equal to name, the name that was passed in. Okay, and we'll go ahead and give ourselves a display method. Let's see, maybe I'll say something like room named self.name, something like that. Just something that gives me a visual representation that this guy's a room object and its name is something, just so I'm able to kind of show it on the screen. Okay, so that's a simple room object right now. Can't really, I mean, it really is very useless. It's just an object that knows how to hold one string right now, but we're going to be adding some abilities to it. All right, but we're going to go ahead and create our Legos. All right, because we need to get a very specialized Lego kit out here that allows us to have rooms with all these names. Okay, so I'm just going to go from bottom to top. So we have entrance, soda room, security sandbox. In fact, actually, I'm going to do something like we did last time that will kind of make life a little easier for creating these for us. So I'm going to go ahead and, well, will this really make life easier? Yeah, I think so. So we'll say, sorry, I'm going to go ahead and I'm going to create a list. We're going to call this guy room names. And room names is going to be a list of strings. I'm going to fill it up with the names of all our rooms. And then what I'm going to do is I'm going to spin through and create a list. You know what? Because of the way we're going to do this, I don't want to do it this way. Sorry. I want to be more explicit. So I'm going to create a room for entrance. So I'm going to say room, we'll call it R1, is a room named entrance. And we decided we're going to need how many? 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 total rooms. So we have 1 so far, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'll go ahead and rename my actual variable names. And you see how that was kind of a little tedious to do that? What we just did there? Let me show you maybe a little trick of something I would have done. I mean, we only had 14 of them. It wasn't the end of the world. And I haven't filled in the strings here yet. But since I know I need 14 of them, I might have done something like for I in range 1 to 15. So they'll go up to, but not including 15. And then I might print Ri is equal to, and this is going to be an F string. And I'll just give myself my placeholder for my actually, I think I can do it like this. I'll just use escape characters. So this will print out R1 equals room, double quote, R2 equals room, double quote, R3 equals room, double quote. So when I run this, there's my output. So I can copy that and paste it in there, and I've given myself a bunch of code now I can fill in. So kind of a quick programmer trick that you could say, I'll just write some code real quick that produce a bunch of these variable starting points for me that I can then go and fill in with other stuff. Make sense? And after I do that, I can just remove this for loop because I already have my stuff there. And then let's see. I think it's just pressing tab will indent these. Yep. All right, so now I have all my variables created. Now I just need to fill in my names of my things. So I'll call this entrance. Then we have soda room, security sandbox. And the same thing, what I just did there, sure, I used it to fill in some code, but you know, there's been times before where you needed to like write something in a paper where you had to like kind of itemize a bunch of things, where you could write a quick little program that will just print a bunch of things for you and give you at least a starting point. So a lot of that tedious stuff that you would have had to type yourself, you could just have your program do it for you and repeat it and fill in what makes it different, which is what we're doing now. So even though I'm using it in my program itself, you could have done this for some paper in an English class or something like that if you needed to create a table or something like that. So kind of tools that a programming language might let you get away with. MATLAB, and then 4 hallways. Two, 3, 4, S120, S118B. Server room, lobby, esports. And then what I call laser cutters. Okay, so now I've created 14 individual instances of my room objects. Make sense? All right, now I want to maybe prove that these guys are individual instances, so I can go ahead and say, I'm gonna print R14, then I'll say print R7. Now, what's the output of this program gonna be when I run it? I'm printing out two things, R14 and R7. What's gonna print out?
The address of the object.
Good. This is gonna print out memory addresses, right? We're creating instances of room. So the value of room here that gets stored in this variable name is the address of this particular room object. So these two will be two separate addresses. All right, so there's our different addresses here. Okay, this is C4C, this is B6C. So these are pointers. You'll actually find if I say R13 and then R14, I'll kind of just show you a point here. All right, so 5B or 5, let's see, 2C, 4C, 2B, 6C. So if you were to take the difference between these, I think you'll get 32 bits, 4 bytes is the difference. Size of a memory address in this operating system. Okay, because these guys are right next to each other. All right, but punchline here is that's more trivia stuff. What you'll do is you're just looking at these and say, I've created, in this case, I've created 14 different rooms. I've used the same blueprint. This guy I defined up here. So I wrote the blueprint once, and then I used that blueprint 14 individual times to create 14 unique instances. Now, keep in mind that several of these, like R5 and R6, both have a name, hallway. But R5 and R6 are unique objects. So even though they have different, or even though they have identical content as far as a human being can look at it, they do live in a different place in memory. We do physically have a room with hallway, and then another room with hallway, and another room with hallway, and another room with hallway. Make sense? All right. So what I'm really trying to drive home here is this idea of when do we create objects? Where do they play into our problem solving? We've decided we want to create a digital map of the department. I've decided that we're going to break this guy down in terms of these things that we're calling rooms. We've represented those rooms with this blueprint, and then we went ahead and created our 14 rooms. Make sense? And now I can tell my rooms, I can print out my rooms here, but I can also say print, actually, I don't need to print it. I would say R6.display, and that will display room R6. If I say R14.display, I ask room 14 to display itself. This one will say laser cutters. Make sense? So when I print it out here, I printed out the value that is stored inside of the variable named R5. I printed out the value that is stored inside the variable R6. The value that's stored in there is a memory address. Okay, very important. Those are pointers, and Python, Java, these modern languages don't give us direct access to those pointers, but they still exist. We see crazy memory addresses right here. That's a pointer. All right. All we need to know as practitioners, programming practitioners here, is that these guys live in different houses. They're in different places in memory. They might be very close to each other, but they are in physically different places. Okay. So when I'm talking about R6, I am talking about the room object that lives at the memory address currently stored inside of R6. And what do I want that guy to do? I want that particular room to display itself, call his display function. In this case, I want to get the room that lives at the memory address stored inside of R14. And what do I want him to do? I want him to call his display function. And their display functions all do the same thing. Why? Well, we wrote it. The display function prints out this particular object's name, self.name. That is the name that belongs to this particular instance of room. Remember what self is. Self is a variable that allows an object to refer to itself from within itself. So what does display do here? It says, it prints out the string room named, and then this is whatever my name is, the field associated that was set up when somebody constructed me. They associated a variable with my field called self.name. And I'm going to just spit out whatever my name is. So if I'm inside of the variable R6, his name is hallway. If I'm inside the variable R14, his name was laser cutters. Built with the same blueprint, lives in different places of memory, has different values. They might look the same, but they are physically different values for their name. Because if I say R7.display, we'll see both of them say hallway, but this hallway lives inside of the instance of the object stored in R7. This hallway lives inside of the instance of the object that's stored in R6. All right, that makes some sense? So this is kind of the purpose of building objects. So now I've laid out 14 Legos right here. Okay, so I have these 14 room objects. I'm calling them Legos because we're going to use them to build our map. All right, so I have these 14 Legos laying out in front of me. So I have individual instances of my room object, but now I need to connect these guys with each other some way. Now in real life, I can kind of lay them out next to each other like we've kind of done here without the little green dots, right? Because the green dots represent how these dudes are connected. That makes sense? Okay, so now I need to decide, well, how am I going to describe how these guys are connected to each other? Well, we might decide, you know what? A room has an exit. And maybe instead of treating these guys as a single object, maybe we treat it as two objects, where this guy has an exit to the south leading to lobby. This guy has an exit to the north leading to laser cutters, for example. All right, so a little bit ago, I had in here that a room maintains something called a list of exits. Now, maybe an exit has a name and it has a room that it goes to, a destination. So you can almost think of these exits like portals. Does that make sense? Makes them feel more sci-fi then. So we can go and we'll create a room, or create an exit rather. So an exit has a name, for instance, maybe north, south, east, west by the examples we've been using so far. And then it also has a destination room, the room that it leads to. Go ahead. You have a question? No, maybe not. Okay. So we're going to go ahead and create our blueprint for our exits now, so that we can start building those. So I'm going to create a class up here called exit. I'm going to define its constructor. It's going to take in a direction or name. Like, what did I write it for? Let's actually call this direction instead of name. So it's going to take in a direction, and then it's going to take in a destination room, the place where it's going to go.
Can I ask you something, Dr. Lippman?
Go ahead.
How come we couldn't like just define a new function called exit?
Inside a room?
Yeah, is that something you wouldn't want to do, or?
Well, it depends how you want it to work. I mean, we can make a function call exit, but then where's that room going to lead to?
I didn't know. I didn't know if it would do anything, you know,
Well, I mean,
if it would mess it up.
you can make a function named that if you want, but ultimately, whatever you put in there is what it's going to do. So, I mean, one thing you could do for a room is you could say, well, rather than having this new kind of object, I can maybe keep track inside of room, maybe a dictionary that holds directions associated with other rooms that it connects to. And then you can maybe have something called take exit in here that takes in a direction, and then it searches through that dictionary for the direction and goes to the room that it's going to. You could probably do that. One issue with that is that would mean that when you first create a room, you have to know the places it could possibly go. So now you have to either create all your rooms ahead of time and then go back in and add that. So it's not part of the constructor. Or you need to make sure that rooms are created in the order, in like the perfect order, so that all the rooms that you might need to add to the exits of this room have already been created, which is probably going to be a problem since coming back to a room is then you get a chicken or the egg problem where a room leads to another room who then leads back to this room that we're currently in the process of creating. So maybe it won't work out so well. But I mean, so the punchline is your question of can't you just have a function called exit doesn't tell me enough. It depends on what you want that function to do. We can create a function called exit, but how is that function going to actually take the exit? That's why I'm trying to show this thing where we are drawing a picture and we're saying, who are the different players? If this is if we're watching like a play, who's on stage right now? Who's taking part in this play? Well, we have some room objects, and then we have these green guys that are connecting those to each other somehow. Okay. And we might say, well, for each thing we see on stage, we're going to create an object, and those objects are going to do their little job. Okay. Not that you can't come up with other ways of accomplishing it or something like that, but try to view it for now through the lens of if I'm watching the play, if I'm hiring people to, if each one of the people in the room, we don't have enough of them for the department, but if each of people in the class all stood up and we say, okay, I want you to organize yourselves in a layout that looks like the department, what you might do is you might decide who's what room, and then you guys are the room objects, and then you might have like strings or something that you hold on to that link to other rooms so you know who leads to where. Something like that. So we need to define an object for the strings, and we need to define an object for the rooms. That's one way we could kind of look at it. So that's what we're trying to do here is by drawing this picture, we're kind of showing that, oh, I'm going to need two different kinds of objects here. The rooms and the things that link the rooms. All right, so I'm going to define exit to take in a direction and to take in the room that leads to. I think you'll see how these are going to stick together here in a second. So we're going to say that this guy will say self.direction is equal to direction. Self.destination room is equal to destination room. So we'll set up those couple things right now. All right. And then we'll go in and just like I did before, we'll say def display. We'll teach an exit how to display itself just for our own visual to see that things got created in kind of the right order. All right. And then we'll go ahead and we'll say, we'll print, this guy will be an F string, and we'll print out exit leading to self.destination room.name. The name of our destination room, something like that. So we're going to be using our exits here in conjunction with our room so that if we were to print out, for instance, hallway, What we want to see is this guy's a room named hallway that has exits to the west leading to hallway, to the east leading to hallway, and to the south leading to entrance. That's from the perspective, if I put myself inside this room, we want that room to have 3 doors, 3 exits, 3 portals, whatever you want to call them, okay? And one of them leads to the west to hallway, one of them leads to the east to a different hallway, and one of them leads to the south to the entrance. All right, so let's go build that one little pod here. Okay, so I mentioned earlier that a room has a collection of exits. Now, when we first put a room into existence, it has no exits in it, but we'll go ahead and initialize the list of exits to the empty list, a list that has nothing in it. So that means when we first create a room as part of this constructor, we'll say self.list of exits is equal to the empty list. So notice here, this is the constructor. I only took in the 1 parameter for the name, but I went ahead and I set another attribute, another field that this room keeps track of, and it's called a list of exits. And I initialize that field to the empty list. Now, having done that, I'm then going to create another function here called add exit. And he's going to take in an exit as a parameter. Now, he actually could take in a, this might be a friendlier way of doing it. He could take in a direction and a destination room. And then internally here,
You have a period there instead of a comma, and it's bugging me.
let's see how much anxiety we can create. All right, let's see. So so it's going to take in self, it's going to take in direction and take in destination. Remember, these are the 2 pieces of information that we need to create for us an exit. So I'll go ahead and inside here, I'll create an exit out of my direction and out of my destination room. And then I want to add that exit to my list of exits. Self list of exits dot append and exit. Okay, so now I have another function that allows me to add an exit to a room. And you're going to see me use this here in a second. So now down here, when I create, let's see, what was the room I was working on? I was working on this hallway. So that was R1, R2, R3, R4, R5, R6, R7. I think R7. Probably could have named them a little bit better to match these, but yeah, looks like R7 was correct. So under R7, I'll go ahead and say R7.add exit. And I'm going to add an exit to the south to entrance, which was R1. You know what? It's going to make life a lot easier if I just go ahead and label these. R2, R3, R4, R5, R6. I'm just labeling them with the variables I created for these guys. R7, R8, R9. Just make sure I still want right to left here for S118B. Yep, R10. R11, R12, R13, and R14. All right, so if I'm looking at R7, I want to add an exit to the south to R1. I want to add an exit to the east to R6. I want to add an exit to the west to R8. So I'm adding exit to the south to R1. I'm going to go ahead and I'm going to add my exits here at the end. That way all my objects have already been created. So R7, add exit to the south, R1. to the east, R6. And to the west to R8. So I initially created all my rooms, so all of these guys exist as rooms. Now what I did is I added this exit, and this exit to room R7, leading to these other rooms. All right, and now to prove that that worked, what we're gonna do is we're gonna go and add a little ability to our rooms. So when a room displays itself, not only will it display its name, it's also going to display the exits, where it leads. All right. So we'll go ahead and say for exit, let's see, we'll call it for the exit in self dot list of exits. We'll ask the exit to display itself like that.
Is that semicolon necessary there?
No, the Java syntax.
Okay.
So the exit to display itself. Now, what I'm going to do just to make this look a little cleaner, inside of display for exits, I'm going to put a little tab. \T is a tab, so it'll kind of indent underneath our rooms. I think you'll see why here in a second. All right, so I've added 3 exits to R7. Then I'll go ahead and tell R7 to display himself. Which I'm actually already doing, but that's fine. So add 3 exits to R7, tell R7 to display himself. Oop. That is where for an exit. So there we have a room named hallway with an exit. We probably should give the direction for that exit. So let's say self.direction leading to that. So hallway, south leading to entrance, east leading to hallway, west leading to hallway. Something like that.
Did you pass that dot name through from the first object we created?
From the first object we created. When I originally created R7, you mean?
Yeah.
Here's name.
Right. So when you pass it to the into another class, it'll still work because you passed it from
You're not, hold on. Let me go through it. You're not passing it to the other class.
Okay.
Oh, here, let's just walk through what's actually happening here. So we have R7. This is where R7 is being created. We're calling the init function of the room class here. This is the constructor for it. This is the one parameter I'm passing in. Right now, this is a string named hallway. So if I come up to room here, the string hallway is coming in right there. What does it have? What is it doing? We are storing it inside of that room's name. And then we're also creating an empty list of exits. That's what R7 will be. It'll be a room that has a name equal to hallway. All right. Now, when we go and create our, what was the other ones that led to? We'll just do this for R1. When I created R1, we passed in entrance for our name. So entrance came in here. This particular room, the room associated with R1, will set its name to the entrance, and he will have an empty list of exits. Now, when we make that link between those two rooms, so down here, when I say R7, add exit to the south to R1, R1 is an actual room object. It already knows what his name is. He contains his name, which is entrance. So when I say add exit there for a room. So this is a room calling his add exit method. So I need to go into the room class and look at what add exit does. And I see here, well, I'm passing it two parameters. I'm passing it a string and I'm passing it another room. So I come up here, what does add exit do? It takes in a string, it takes in another room. I am using that string and that other room to build for me an instance of exit. Instance of exits were defined right down here. To build an exit, we need a constructor. The constructor takes in a direction and the place, the room that this exit leads to. And this exit sets his direction to whatever the direction was. This was to the south. He sets his destination room to wherever it leads to, which was to R1. This was from R7 to R1. So the destination of this exit is R1. Now, when we go to display this exit, notice I'm saying exit, display your direction. But when I display the room it leads to, the exit does not get the name of the destination room. It gets the destination room. So I'm saying self.destination room, which is a room. I'm then asking that room to tell us what his name is. So the exit never actually was past the name of the destination room. It was past the destination room, whom I could then ask, what is your name? Does that make sense?
Yep.
So that's how these things are connected to each other. If I go to my picture here for that, I'll explain the same thing I just did, but I'll do it in the picture form. So when I had R1 and I had R7, I added this exit to R7. And this was an exit leading to the south leading to this room. This room here already knew his name. So when I ask R7 to display himself, he displays, hey, I'm R7. Well, he actually displays, hey, I'm a room that's called hallway, and my exits are to the south. He went and got this room and said, room, tell me what your name is. And this room is who reported his name. Hallway did not have to remember his name. Question? Go ahead. Correct. Yeah. So if I don't put .name here, the value of the destination room is a memory address. So here's one to the south leading to this object. Here's one to the east leading to this object, so on and so forth. But I'm going to ask that particular room to give me his name. Okay, so now we have our R1 or R7 leading to all the three rooms it leads to. All right, so I'll go ahead and put up what your homework assignment is going to be, and I'm going to give this to you as a starting point. I'll put this up in Slack. Our homework is going to be to complete the rest of the linking between our rooms and exits for the code that is currently on Slack. So what I have already done is I've already hooked up R7 to his exits, but now you need to say R1, add an exit to the north to R7. R2, add an exit to the north to R5, add an exit to the east to R3, so on and so forth. Create all the other links, okay, off of this picture. All right, make sense what I'm asking you to do for homework? Okay, so now we're gonna keep going here because I'm gonna go a little bit farther to kind of show what we're gonna do next class. And I actually might start it a little bit this class just with the links we've already made. But ultimately, now so once this is done, now I've effectively created this link of objects, right? I have a bunch of room objects linked together through exits. Now, the computer science suite over there exists, but knowing that it exists doesn't do us so well. How do we know that it looks like this? How do we know that this is the organization of that? We've either walked through it before, or we viewed the building documents for the university or something like that and saw how it was laid out. It probably didn't name the rooms as well. But one way or another, our experience has been that we have been in that area, or at least you know somebody who you trust who's been in that area and you believe what they're saying here, right? Okay, so with that in mind, if we want to test to make sure our connections here are good, I mean, I've kind of sort of tested here, right? I've looked at my output and my room hallway has south, east, and west. It seems to be leading to the correct places. Here, let me run this again. Seems to be leading to the correct places. So it seems like I've linked up at least room 7 correctly once I get the other ones linked up. But to really experience it, what I'd love to be able to do is I'd love to have another object involved here, maybe called a student. And a student can walk through the department. Maybe we dump them into the entrance, right? And then so initially, we just teleport you to the entrance. And then once you're in the entrance, then we say, where do you want to go next? And you look around and you say, well, I have 2 choices. If I'm in the entrance, I can leave, so I can exit the program, or I can go north. Then I'll show you this room. If I'm in this room, where can I go? Well, I can go back south, or I can go to the east, or I can go to the west. So we can start walking through our world. Make sense? So now I've created a map. We've now introduced a new thing here. So I'll go ahead and we have what does a person look like? Maybe a star. So we initially maybe put that person right there. And then we say, where do you want to go? They say north. We move them to the north. Now, where do you want to go? They say east. We remove them from this room and we add them to this room. How do we get to this room? Through this exit. Make sense? So if we're thinking about this in terms of how do these objects work with each other, and we want to kind of think about it in like a sci-fi type thing, because this isn't the way it works in real life. Ultimately, in real life, if I go from this room to this room, I just start walking towards this door. Well, actually, there isn't even a door, right? I walk through the opening that leads to this next section of the hallway. But the way we're kind of thinking about it here is that these are individual rooms that are all like linked together through almost like an airlock, something like that. Or if you want to get super sci-fi, it's like I don't know, one of those like Stargate looking things, and it teleports you through there to some other place. Okay, so the way it would work here is I would, like, if I'm in room R7, I would look up at the sky. I would say, remove me from R7 and take me to the east. So the room would pluck me out of its list of inhabitants, the people that are currently in that room, right? And then it'll throw me through its portal, which leads to this room, and it'll add me to this room. Imagine if that's how real life worked. It'd be cool for like a day, an hour, maybe an hour. Then it'd get kind of annoying if every step you took required you to teleport to a place 5 feet in front of you. But that's effectively what's going down here. Okay, so if we're thinking about the mechanics of how do I represent movement through this map that I've designed, because I've chosen this design to be how I'm going to represent my map of the department. So now I'm going to put a person in here. Okay, so I'm going to put a person in. I'm going to say each one of these rooms is capable of holding. Initially, maybe it's just a person or a student or something like that. Current inhabitant, something. Okay, and I'm going to start calling it inhabitant. Well, let's see. Yeah, I'm going to call it inhabitant now because where we're trending with this is to start talking about something called inheritance. Inheritance is just a little foreshadowing, is a way that we can use one class as the base class for other classes. So for instance, in a room, like in this room right here, we have inhabitants. So in this room, what we have 5 total people in this room, right? Okay, so we have 4 students and we have 1 teacher. Now, all of us though are humans, right? We're all inhabitants of this room and we all have mostly the same characteristics, but there are maybe some differentiating things, okay? Now you start putting it into a video game setting. Now we can't just say they're all persons, right? Because we might have monsters in this room that also attack, right? Because that's how games work, right? You have to have enemies, all right? So we might say there are inhabitants in a room, and right now we have 2 different kinds of inhabitants. We have students and we have teachers. So four instances of students, 1 instance of teacher, and then maybe we have a instance of a monster, which would be a fairly scary school experience, but things could happen. It is 2020, right? Isn't that what they say? Zombies or something. But in any case, as we're going down that, we're going to say that all inhabitants have something in common. Maybe we all have names, right? The teacher has a name, the student has a name, the monster has a name, but then they have some different attributes past that. All right, maybe the monster has a mind of its own because a human being is not controlling the monster, right? You know, that like in video games, you might call that an NPC, a non-player character. So it's going to be like this computer controlled entity, and it might be hostile towards us and start just attacking us randomly. It might only attack if we mess with it, something like that. So, but we're going to have this concept moving forward of different kinds of things can inhabit our rooms. But initially, we're just going to call everybody inhabitants. It's a generic inhabitant. And actually, initially, we're only going to allow our room to have 1 inhabitant. And then we're going to upgrade it from there. We're going to let a single inhabitant enter the entrance and then start walking through the department saying, ah, this is awesome. Something like that. Okay. So let's go and look at that. So I'm going to create an inhabitant. And an inhabitant is going to have a name. Now, we can ask ourselves, so now we're starting to think about what are some things an inhabitant might know. How many of you know what room you're currently in? You don't even have to know the name of it. You just know that you're in this room. All of you have that knowledge, right? So if we're trying to model this, we might say that if we put this inhabitant in this room might know that he has this inhabitant in it if the room had a mind, right? But we also might say that this inhabitant also knows that he's in room R7. That might be something that's convenient for inhabitants to know, for them to know what room they're currently in. Make sense? So we're going to say that for an inhabitant, not only will they know their own name, they'll also know their own current room, the room they're currently in. How they become aware of that is going to be kind of up to us. The way I'm thinking about this is as we add them to room R1, for example, so when they first come in here to room R1, so I put them into R1 then notifies them that you have now entered R1. Here's a link to me. And that'll let us look at self a little bit closer. Okay. So now we need to upgrade room a little bit. Not only does it have a name and a list of exits, it also has a current inhabitant, which will start off as none initially. So if I look at my map here, we see that most of our rooms do not have an inhabitant in it. As I currently am depicting it, only this room right here has an inhabitant. Okay. So we're going to upgrade room to also have a single variable that keeps track of who's currently in the room, 0 or 1 people, 1 inhabitant. So let's go and modify our room object for that. So we're going to say self.current inhabitant is equal to none. When a none is like nothingness, null. When a room first is initialized, when it first comes into existence, it's a room that has a name, 0 exits, and nobody in it. Then we start modifying it from there. Make sense? That's the job of a constructor. Constructors construct this object. They initialize it to its initial state. Then we can start manipulating it from there.
So you could not put 0 there. You'd have to use like null or none.
Well, you actually could put 0 here because Python is a loosely typed language. So none is the null pointer. So this is an address that points nowhere. But technically, since Python is a loosely typed language, I could put the string LOL here if I wanted to, and that means nobody's in there. And then later on, I can actually put a memory address there that points to another actual object, because Python allows me to create variables that don't have a label on them on what kind of value they're meant to hold. So I can hold a number or a string 1 second, and then I can hold an actual instance to inhabitant another second. Good programming practice should probably say that if I'm going to hold pointers to other objects in there, I probably want to initialize it with a nothing pointer. What was your other question? I heard you start saying something else.
Yeah, well, I kind of thought through it, but I was wondering if none is like considered like a Boolean operator then, sort of.
No, none is what it's called in Python and other languages. Sometimes it's called null. In other languages, it's called nil. So this is nothingness. It's a memory address to nowhere. So it's kind of our way of saying 0, but in terms of memory. It's memory pointing nowhere.
And it has no value, right?
Correct. It has no actual value.
It's 0 actually has a value.
Yeah, but how you use the value, I don't know that makes a difference. It's how you use the values that has meaning. So if you ask if something is equal to none, you're basically asking, does this point nowhere? If it points nowhere, then I don't want to show who else is here. And what I mean by that, when I display a room, for example, I display the room name, I then go through and display all of its exits, and then I might ask a statement here. I might say, if self.current inhabitant not equal to none, then I might print also here self.current inhabitant dot name, something like that. But I might only do that if my current inhabitant is something real. So if my current inhabitant is something other than none, that means there is somebody in the room, and I'll go ahead and print out also here is Mike, something like that. All right, so that's a use of how we might use that none to decide, does this guy point anywhere? So that's display for room, but let's go ahead and write inhabitant. Class inhabitant. Now notice that classes do not go inside of other classes. So we are writing them as these separate pods, and then we're using them together as the puzzle pieces to represent our scene. Or like, I think thinking about this like a play makes some sense. It's a scene in a play or a scene in a movie, and we have to decide who are the things that are on screen currently right now that we need to create instances of so we can set up how things look right now. So class inhabitant is going to have our constructor. What time is it? We're good, 5 minutes. Going to have our constructor, and this guy will take in a name. And we'll go ahead and we'll say self.name is equal to name, and then we'll say self.current room is equal to none. When an inhabitant is first born, it does not have a room. Okay. So that'll be all an inhabitant can do right this second. So now what we'll do, now that we have inhabitants, we want to allow a room to add an inhabitant. We also want to allow a room to remove an inhabitant. So this is what I was talking about earlier, where maybe you say, oh, I want to go into the next room. You say it out loud, kind of like you're talking to Siri or Alexa or something like that. And you're asking the room to teleport you out of this room and into another room. So you're asking the room to remove me from this room and put me into the next room. Okay. So we'll go ahead and define remove inhabitant. And we don't need to give it any parameters, because right now a room only has one inhabitant, right? And this guy will temp self.current inhabitant. So we'll preserve that value. Then we'll say self.current inhabitant is equal to none. Now he's been removed from this room. And then we'll go ahead and return temp. So if we're thinking about from a room's perspective, if we ask a room to remove an inhabitant, the room will temporarily store that inhabitant in another variable. Then he'll forget about him having the inhabitant. He'll reset his variable for current inhabitant to nothing. And then he'll go ahead and return the inhabitant he just removed. Whoever asked him to do that gets that guy. All right, he can do with him whatever he wants. Okay. And this is just the way we've decided to do this. We say, room, remove me. The room says, okay, hold on. And the room yanks you out of existence and gives you to whoever asked that. Okay. Now we're going to have a way of adding an inhabitant. And we'll add an inhabitant. We're going to need a inhabitant to pull that off. And what we'll do is we'll say self.current inhabitant is equal to an inhabitant. But then we also need to let that inhabitant know that their current room is this room, the room we just added them to. Okay, so we're going to say, and by the way, add inhabitant or an inhabitant. I could also say self.current inhabitant. They're the same thing right now, because after this line, they both hold the same value. So self.current inhabitant, your current, and they call it current room. Yep, current room. Your current room is going to equal the room you're standing in right now. How does this instance of room tell this current inhabitant that he's in this room? How does
With
a
the
room
display function?
How does a room refer to itself from within itself? Because really a room is trying to tell this inhabitant, I've just added you to me, to myself. How does an object refer to itself from within itself?
Self.name.
Isn't it just self? Isn't self the name of, isn't self the address of this room? So this is setting the current inhabitant's current room equal to self. That is this room. Not a room with the same name as this room, but this actual room. This is passing it a pointer to this actual room. So then down here, we'll just do a quick little example. Since we're almost out of time, I'll go ahead and after R7, I'll create an inhabitant. Say Mike is equal to, actually let's call it the inhabitant is equal to an inhabitant whose name is Mike. And then we'll say R7 dot add inhabitant, the inhabitant. And then we'll say R7 dot display. And we'll see the first time we displayed R7, it doesn't show any inhabitants in there. But the second time it notices, oh, somebody's been added. Also here is Mike. That makes some sense? So next time you'll have all of the rooms linked together, And then we're going to go ahead and start moving our inhabitant through the world. And then we're going to give them a prompt to let them negotiate the world, saying go north and south and east and whatever, stuff like that. All right, makes sense where we're going with this? And then we're going to let them do other things in there, like fight monsters and fight other players and that kind of stuff. Okay. We're also going to be moving towards how to represent our map offline instead of hard coding all of it like this. We're going to look at JSON. We're also look at databases and how to store stuff outside of our program so we don't have to write all this stuff like this. Okay. All right. Questions, comments, concerns, bribes. I'll put the homework assignment up and I will see everybody on, what day is it? Thursday? I'll see everybody on Tuesday. Have a good weekend. So hopefully this is starting to feel like some of the things are starting to come together and why we're doing these different things. And then you'll be able to start inventing stuff.
Sir,
Yep.
can I get the codes by Slack?